Hello guys, welcome back to Numboid. Today we're going to go over some questions on L'Hopital's rule. So this will be a great video if you just want to try some questions. I would recommend pausing it, having a go, and then we'll walk through them together. So let's get straight onto our first question here. So our first question here is the limit of x towards 2 of x cubed minus 7x squared plus 10x all over x squared plus x minus 6. Now the first thing you've got to do is to make sure this actually tends to either infinity or 0, so you can know that you can use the L'Hopital's rule. So we're going to put x equals 2 into this, so we get 2 cubed minus 7, 2 squared plus 10 times 2 all over 2 squared plus 2 minus 6. This gives you 8 minus, that's 4 minus 28 plus 20 all over 4 plus 2 minus 6. And then this equals out to be, plus the 20 and the 8 give you 28, minus 28 gives you 0, and 4 plus 2 gives you 6 minus 6 is 0. So we can use L'Hopital's rule. So what we do is we differentiate the top and differentiate the bottom and then apply this limit once again. So if we differentiate the top, we'll get 3x squared minus 14x plus 10, and on the bottom we'll get 2x plus 1. So now we put our limit in, limit of x towards 2, and this gives us 2 squared minus 14 times 2 plus 10 all over 2 times 2 plus 1. So we get 2 squared, which is 4, times 3 gives you 12, minus 14 times 2 gives you minus 28, and plus 10 on the end, all over 2 times 2, which is 4, plus 1 gives you 5. So I'll actually write that split up because we wrote the top one split up. So this gives you, if we 12 and 10 gives you 22, and then minus 28 gives you minus 6, over 4 plus 1 gives you 5, and that is your answer for the first question. The answer of limit of x towards 2 of x cubed minus 7x squared plus 10x over x squared plus x minus 6 equals this, which equals minus 6 over 5, and that is your final answer. Well done if you got that right. So our second question here is the limit of omega towards minus 4 of sine pi omega all over omega squared minus 16. So first thing we have to do is to test whether we can use L'Hopital's rule by putting in this limit. So sine of minus 4 pi over minus 4 squared minus 16. So this gives us minus 4 pi of sine is just 0, and minus 4 squared, it gives you 16, minus 16 is 0. So we can use L'Hopital's rule. So now all we have to do is differentiate the top and bottom and apply the limit. So we put the limit of omega to minus 4 sine, because we're differentiating with respect to omega, we just take out our coefficient, which is our pi, and then differentiating sine, we get cos pi omega over 2 omega, and then because there's no omega with this, the coefficient is the power of the omega is already 0, so differentiate to the front gives you 0, so it just leaves you with 2 omega on the bottom. And now we apply our limit, so we have pi cos minus 4 pi, so brackets there, all over 2 times minus 4, and cos of minus 4 pi is just 1, so we get 1 times pi gives you pi over 2 times minus 4, which is minus 8, so I'm going to put 8 here and then minus up here. So our answer to the limit of omega towards minus 4 of sine pi omega over omega squared minus 16 is equal to this, but is also equal to pi over 8, and that is your answer. Well done if you got that right. Let's move on to our third question. So here's our third question. We have the limit of t towards infinity of the natural log of 3t over t squared. So first thing we got to do, make sure you pause and have a go at this, or you can just watch me go through it, but the first thing we got to do is to test if we can use L'Hopital's rule by applying our thingy. So the natural log of 3 times infinity doesn't really need the 3 because it's infinity anyway, but we'll put it in, over infinity squared equals infinity over infinity. So we can use L'Hopital's rule. So the first thing we got to do is differentiate the top and bottom. And we know the differentiation of natural log is just 1 over t over 2t, which is equivalent to the limit of t towards infinity of 1 over t times 1 over 2t, which gives you 1 over 2t squared. Apply your limit, which is infinity. So this is 1 over 2 infinity squared, and as we know, infinity is already large, so squaring it and times by 2 just makes it infinity again. So this tends towards 0, so our answer is 0. So the limit of from t towards infinity of the natural log of 3t over t squared equals 0. Well done if you got that right. Let's move on to our final question of this video. So our final question here, quite a tricky one, is the limit of z towards infinity of z squared plus e to the 4z all over 2z minus ez. So the first thing we're going to do is to see if we can apply L'Hopital's rule. So we put our infinity in, so infinity squared plus e for infinity all over 2 infinity minus e to infinity, which we all know, we can all probably see, is just infinity over minus infinity because exponentials go faster than infinity. But this proves that we can use L'Hopital's rule. So now we're going to differentiate the top and bottom. So limit of z towards infinity with respect to z, so this gives you 2z. I'm going to put a cross through my z's, plus 4e4z over 2 minus e to the z. So now we're just going to put on our limit again. So we get 2 infinity plus 2 infinity and beyond, plus 4e for infinity over 2 minus e to the infinity. And as we can see, this again will just equal infinity over minus infinity. So the trick here is to apply it once again, because as we can see, we've proven that we can apply L'Hopital's rule. So we do it once again. We've got to differentiate the top and bottom of this one now. So the limit of z towards infinity, 2z just gives you 2, plus 4 times 4 gives you 16 e to the 4z, all over 2 hasn't got a z, so it goes to 0, minus e to the z is just that. But we can change this up and make it look a bit nicer if we bring the bottom e value to the top, e to infinity. That's a terrible infinity sign. Oh, I've lost the ability to draw. There we go. So we can just put brackets here and put 16 e to the 4z, and this becomes minus z on the power here. So this equals the limit z to infinity of 2e to the minus z, minus 2e, sorry, minus 16 e to the 3z. So then we can just put in our limit here, so we get minus 2 e to the minus infinity minus 16 e to the 3 of infinity here. But as we can see, even though this is a minus infinity and this is 3, this one will tend faster to infinity, so this will just equal, and there's a minus in front, minus infinity. So your answer for this tricky question here is just minus infinity. Well done if you got that. Thank you guys for watching. Make sure you hit like, subscribe if you enjoyed this video, and I will see you in the next video. Goodbye.